about exponents and how they function within the order of operations. Okay, now we're getting to the end of it, so we need the last two pieces of information to get this done, and that would be exponents. In the next video we'll talk about square roots. So an exponent's a pretty simple concept. So right here I have a problem laid out already. So I have 2 to the third, where 3, that's your exponent. Okay, exponent, sorry, spell right. Yeah, my pen's not functioning right now. Okay, so 2 to the third, that's your exponent, and 2 is what's called your base. Okay, so 2 to the third, it's pretty simple. Just remember, this doesn't mean 2 times 3. That drives me crazy when people do that. This means 2 times 2 times 2. So there's the 1, 2, and 3. It's 2 times itself 3 times, so naturally this would be 8. Okay, so anytime you have an exponent, the exponent just basically means we know we're going to multiply this amount of times. Instead of writing it 3 times, I can do this and it'll simplify it for you. So like, for example, if I had something like 2 to the 5th, that means 2 times 2 times 2 times 2, and you guessed it, times another 2. You actually multiply all 5 of those, you get 32. Okay, so when you're working with exponents, they appear quite frequently in some formulas, depending on how many calculations you have to do, but you need to know what they do. Like the most common mistake I see people like with a problem like this, if it's in the middle of order of operations or something, they'll panic and they'll be like, 2 times 5, that is 10. But the well-educated math students that you are, you'll realize that is a ridiculous answer. Because if they wanted to write it as 2 times 5, they'd write it as 2 times 5. Now, how exponents function within the order of operations, if you recall earlier in the course, we talked about the order of operations. I know it feels like forever. We talked about PEMDAS, which P is for parentheses, E is for exponents. Multiplication and division are their own group, and addition and subtraction are their own group. So now we're just going to go with the full spectrum of numbers here. So when you have a bunch of operations going on at once, like let me get a problem here. So like if I have 3 squared plus 5 to the third. When I have a problem like this, and we're following PEMDAS, we kind of go through our natural progression. Okay, do we have any parentheses? No. Do I have any exponents? Yes, I do that first. So I do 3 squared, which means 3 times 3, which is 9. Okay, didn't use a plus sign, so bring it down. 5 to the third, which means 5 times 5 times 5. That is 125. Okay, and then we just add the 2. So we get our final answer of 134. So, all really the exponents do is they just kind of add an extra thing we have to look for. All the order of operations problems we did earlier, all you had to do was really just add, subtract, multiply, and divide. Now we're just going to get into more intricate calculations. And we can write this in a bunch of different ways. It just kind of depends how it's written. Probably variation you can see on one of these problems is something like this. Where we have, say we have 14 divided by 2, and then that's in parentheses, and then I want to raise this to the second power. So here's kind of a slight variation. People might be inclined to think, oh, I do 2 to the second first, but no. Notice 2 is on the outside of the parentheses, so we do what's inside the parentheses first. So you do 14 divided by 2, which is 7, and then we bring the squared down. So then you do 7 to the second, which is 49. Okay, so with an exponent, just remember an exponent is a multiplier. The exponent up here tells you how many times to multiply the base by itself. And when these are in the order of operations, you have to do the exponents first before you get into the 4 basic operations. Okay, but other than that, I don't think they're really anything too difficult. Just make sure you realize that you times the base by itself as many times as the exponent tells you to.